Okay, so let's look at this question. We have u square plus u minus 2v minus 1 whole square minus 4v u plus v. Then what is the value of u plus 3v? Okay, let's say we have u square plus u minus 2v minus 1 whole square. Let's expand this bracket. 4 minus 4 vu minus 4 v square. Let's see, let's expand this one as well. So it becomes u square plus 4v square plus 1 plus 2u minus 2v plus 2 minus 2v minus 1 plus 2 minus 1 comma u. So this is the formula for a plus b plus c whole square. It is a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So this is the formula that I have used here. I'll just keep it here for a while, you can look at it, and we see minus 4vu minus 4v square. Okay, let's erase this formula right here so we get more space to write. So this becomes 2u square. This 4v square goes to here and becomes 4v square plus 4v square 8v square plus 1 plus. Now this 2 2s are 4 minus, so this becomes minus 4vu. This becomes plus 4v and this becomes minus 2u is equals to minus 4vu. This 4vu goes and we have a final equation which has terms of 2u square plus 8v square plus 1 plus 4v minus 2u equal to 0. Now when you look at this equation, you can clearly see there is no term of u and v in it, right? When there are no terms of u and v in it, then there is a certain method which is basically converting these one equation into two quadratic equations in u and v. Okay, so what we are trying to do is figure out values of u and v, but to do that we have to solve this equation, right? This equation in itself is complicated because this is the sum of two quadratic equations, because there is no uv term. If it was a uv term, then this is not a sum of two quadratic equations. Okay, let's look at the points now. 2u square, let's take all u square parts in one place and v square and v parts in another place. We've got 8v square, we've got 4v and minus 2u plus 4v, and let's take 1 on this side, okay, which is minus 1. It was plus 1, will become minus 1, right? This will go this side. Okay, so this is the equation 2u square minus 2u plus 8v square plus 4v. Okay, what we'll do is we'll try to create a quadratic equation out of these terms. What can you take common from these two? We can take 2 u square minus u. If let's say I had u square expansion of u minus x square, what will it become? It will become u square plus x square minus 2ux, right? The first term of u square matches here. Hence, we can assume that by some addition and subtraction, we can get this to convert into this. Okay, so let's compare this term so that we can get x. Minus 2ux is equal to minus u. U cancels, minus minus cancels, x becomes 1 by 2. So basically what I'm saying is u minus 1 by 2 square is u square minus u plus 1 by 4. In this condition, what is missing? Just this value. So what we do? We add that value in it. Okay, I'm just erasing certain part of it. So I'll just keep this for reference. So if I have to convert u square minus u plus 1 by 4, I'll just minus 1 by 4 as well. So it is same, right? What we want is only these three terms. So what happens to this? We take it out of the bracket. Out of the bracket it goes. What it means is 2u square minus u plus 1 by 4 minus 2 into 1 by 4, which becomes 1 minus 1 by 2. Fair enough. This minus 1 by 2 will go to right hand side. Okay, so my final equation here becomes 2 times u square minus u plus 1 by 4 minus 1 by 2 to u minus 1 by 2 whole square. This minus half will just add to, this will go to the right hand side and get added. We'll just add 1 by 2. Fine. This went to RHS. I understand this is a bit complicated, but you need to understand how to create these equations, right? This is just equation manipulation. Let's look at the V part now. What can we take common from maximum from this, right? We can say, let's say, we can take 4. The remaining part will be 4 to v square plus v. Now this part is not a easy squared person. Like if I say I have to get 2v square, root of 2v square will be root 2 into v, right? So instead of doing that, because I can see that my 2ab term is not in root 2 terms, what I do is, instead of taking 4 common, I take something else common. Let's say 2. I take 2 common because I cannot take 8 common. So I take 2 common. 4v square plus 4 plus 2v. Now let's see. This is a perfect square. Yes. And we have some 2ab term as well. So let's see. 2v, which is 4v square root is 2v. So 2v plus x square, I need to make this in this form. So what should it become? 4v square plus x square plus 2 into 2v into x. Fair enough. 4v square matched, 4v square matched. X square will add it. Now this term should be equal to 2v. So 4vx is equals to 2v. 2 1s are 2 2s are. V gets cancelled. X in this case as well becomes 1 by 2. Now what we do is, we just make the same adjustment that we did here. Okay, I'll just rub this off. What adjustment do? We make, here it was 1 minus 1 plus 1 by 2. We get 2 into bracket 2v whole square plus 2 into 2v into 1 by 2, right? Now I need to get 1 by 2 square, which is 1 by 2 whole square, which is 1 by 4, and I'll just minus it as well. 1 by 2 whole square. Now this is the entire term. This is equivalent to this, right? Now what we do is, we just take these three terms in one place. 2v whole square plus 2v plus 1 by 4. We take this out of the bracket. This becomes minus 1 by 2. Again, this will go to RHS, in which we'll just add half again to RHS. What this becomes is 2 times 2v plus 1 by 2 whole square. Right? Now the total overall equation looks something like this. Now here, if you look carefully, minus 1 plus 1 by 2 from this point and plus 1 by 2 from this point. So we get 0 as RHS. So we got 0 as RHS. We got 2 into bracket u minus 1 by 2 whole square plus 2 into bracket 2v plus 1 by 2 whole square. Now this is something that I can work with, right? 2 u minus 1 by 2 whole square plus 2 2v plus 1 by 2 whole square is 0. That is the equation that we got. When we look at this, how can this equation be 0? Either this whole term goes to 0 and this whole term goes to 0. There is no other case. Both of them will have to get to 0. How do we do this? 2 u minus 1 by 2 whole square is 0. U minus 1 by 2 whole square is 0 because 2 goes to that side and becomes 0. U equal to 1 by 2. This is a quadratic equation with equal and real roots. Again we do the same thing for this. 2 into 2v plus 1 by 2 whole square is 0. 2v plus 1 by 2 is 0. 2v equal to minus 1 by 2. V is equals to minus 1 by 4. Now we got u and v. Now we can calculate u plus 3v. So if we go u plus 3v, u is 1 by 2 plus 3 times minus 1 by 4. This becomes 1 by 2 minus 3 by 4, which is, we will just adjust the denominators, 3 by 4, this becomes minus 1 by 4. The option is D. This was a bit long in terms of solving, but this is a really good question to develop your concepts of quadratic equations and your ability to stay with the question accurately and consistently to figure out how to get to the point where you can solve and get the answer. If this type of question comes in the exam, it would not be my recommendation to solve it. Okay, but this is good practice. I'll see you in the next one.